Alright guys, so today's video is going to be about laws of indices. In the first video we have looked at law 1 and 2. So today we're going to be looking at law 3, 4 and 5. So in example 1 over here we see a situation of 5 to the power of 2 to the power of 3. So it's similar to what we'll be looking at in law 3 of a to the power m outside power n. So 5 to the power of 2 to the power of 3 becomes 5 to the power of 2, 5 to the power of 2, and 5 to the power of 2 getting multiplied together. Alright, and we're going to use law 1 over here to try to summarize this situation. Because all the bases are the same and they get multiplied together, what I can do is one single base 5, the power all gets added together. Now, this is the same as having 5 to the power of 3 groups of 2. And this is numerically equivalent to having 5 to the power of 2 groups of 3. Now, this becomes a very important observation because look at the power here, 2 and 3, they seem to get multiplied in the end. So let's try to summarize our observation. 5 to the power of 2 outside power 3 becomes 5 to the power of 2 times 3. In part 2, let's see whether this similar thing is going to happen. So I have a to the power of 3, 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 a total of 4 of them. They all get multiplied together. And again, I'm going to use law 1 because all the bases are the same. So all the power gets added together. Okay, so 3 plus 3 plus 3 plus 3 becomes 4 groups of 3. And numerically, it is also equivalent to 3 groups of 4. Once again, we have the situation of a to the power of 3 outside power 4 becoming a to the power of 3 times 4. So we're now prepared to generalize this into a to the power m outside power n. This becomes a to the power m times n. Okay, so in the next example, in example 2, we'll be looking at the situation for law 4. So in law 4 over here, in example 2, we have 2 times 5 to the power of 3. So this is a similar situation to a times b to the power of n. So let's see what happens. So power 3 means there are 3 2 times 5s appearing. And they all get multiplied together. Now we're not going to multiply 2 times 5 because we want to see what happens to the power 3. So I'm going to put all the 2's together. So they all get multiplied together anyway. And all the 5's go together. So I regroup them and they still get multiplied. And this can be summarized into 2 times 2 times 2 becomes 2 to the power of 3. 5 times 5 times 5 becomes 5 to the power of 3. And now we have a very simple outcome. 2 times 5 to the power of 3 simply becomes 2 to the power of 3 times 5 to the power of 3. Notice that the power appears to get distributed to each of 2 and 5. So let's try to summarize this. 2 times 5 to the power of 3. The power 3 appears to go inside and become 2 to the power of 3 times 5 to the power of 3. In part 2, we have again a similar situation. So now I have a times b, a times b, a times b, and a times b. Total of 4 of them. And they all get multiplied together. Again, all the a should go together. So I have a times a times a times a. Total of 4 of them. I have b times b times b times b. All the b's go together. And it summarizes into a to the power of 4 times b to the power of 4. Once again, let's observe that the power 4 appears to get distributed to a and to b. So let's summarize this. A times b to the power of 4 becomes a to the power of 4 times b to the power of 4. Now observe that the power 4 goes into each of the a and b and becomes their power. So likewise, I can summarize this a times b to the power of n becoming a to the power n times b to the power of n. So that concludes law 4. So in the next example, we'll be finishing off with example 3 for law 5. So in law 5 over here in example 3, you can see a similar situation of 2 divided by 5 to the power of 3. So that's similar to a divided by b to the power of n. And we're going to see what happens over here. So 2 divided by 5 is similar to 2 over 5 and outside power 3. So we're going to use fraction to try to help us understand this situation. 2 over 5 to the power of 3 simply means I have 2 over 5, 2 over 5, and 2 over 5. And they all get multiplied together. Now you learn that in fraction, when you multiply the fractions, the numerator gets multiplied together and the denominator gets multiplied together. So in the next line, I have 2 times 2 times 2. All the numerator gets multiplied together. All the denominator gets multiplied together. And that summarizes into the situation 2 to the power of 3 over 5 to the power of 3. And once again, we see this power 3 appears to get distributed to the numerator and the denominator of the original fraction. So we have 2 divided by 5 outside power 3 becoming 2 over 5 outside power 3 becoming 2 to the power of 3 over 5 to the power of 3. Again, this 3 appears to get distributed into each of 2 and 5. So in part 2, I'm going to see whether this happens again. So we're going to take similar approach. A divided by b is the same as a over b and outside power 4. And now I also do the same a over b times a over b times a over b times a over b. Okay, and the numerator all gets multiplied together, a times a times a times a, and denominator has b times b times b times b. So I summarize this into a to the power of 4 over b to the power of 4. Again, the power 4 outside seems to get distributed into each of a and b's. So I have this situation here, a divided by b to the power of 4 becoming a over b to the power of 4 becoming a to the power of 4 over b to the power of 4. So now we're prepared to generalize law 5, and a divided by b to the power of n becomes a over b to the power of n becomes a to the power n over b to the power of n. So I have here generalize a over b to the power n becoming a to the power n over b to the power n. So this concludes the discussion on the 5 laws of indices. Please feel free to head over to whichever video in the link below in the description part, so you can actually just click the link to go to whichever laws or definition you need help in. Otherwise, please feel free to press like if you like this video, and subscribe to my channel if you feel that it's been helping you. All right, thank you and see you the next time.